that I can make it available. I said that I won't be recording, but that is people who can't make it, probably they can watch it later. All right. So let's start with the matter. So how do you define matter? Anyone has any idea?
Yeah.
Matter is anything which has mass and volume, right? Matter, anything that has mass and volume. Volume is due to the space that it occupies. For example, we human being, we have mass, but that mass is known as our body weight. Yes? And we also occupy volume. So we can actually calculate how much is our volume by going underwater. Is a method by which we can actually measure. So measurement. So matter has measurement, right? Hi. Okay. Measurements. I'm hearing my own echo. Measurements are Simba. I think you.
Joy, I think you have to mute yourself.
Can everyone mute? Something is speaking up. Yeah. All right. Units and symbols. So without unit and symbol, it becomes meaningless, right? For example, if I say my body weight, I have to have a unit followed by symbol. For example, my body weight is 70 kilogram. So you have a unit which is followed by a symbol. So if you say 70, it does not have any meaning. If I say kilogram, it also does not convey anything. So we should have a number followed by a symbol, units and symbol. Anyone has any problem with that? All good? Can you, the video, someone has to.
All good.
Video should be switched off because otherwise it will, yeah. All right, important elements and their symbols. Elements are represented by symbols. For example, C for carbon, Na for sodium. So you have elements with a single letter, you have elements with the two letters. If it is a two letter, the first letter is a capital letter and the second letter is a small letter. Same way, Cl for chlorine. I will pull out the periodic table and show you which elements and symbols that you need to know. Okay. So these elements are actually organized in a periodic table. In the periodic table, we have groups, which is vertical, and horizontally we have the periods. So we have 8 groups and 7 periods. Okay. In groups, you have the Roman numerals as well, 1 to 8 Roman numerals, or the IUPAC system, so they have 1 to 18. We also have in the periodic table A's and B's. The A's are the representative elements or the common elements, and the B's are the transition elements. Okay, I will pull out that very soon. Elements are made up of atoms. Atoms are made up of subatomic particles. The subatomic particles are electrons, protons, and neutrons. Where do we find the electrons? You can unmute. People can talk.
In the shell.
In the shell.
Orbiting the
Electrons
nucleus.
are found in the shell. And protons and neutrons are in the
Nucleus.
nucleus. Electrons are, what is the charge of electron?
Negative.
Negative charge. Protons,
Positive.
neutrons,
Neutral.
Electrons don't have mass or negligible mass. protons and neutrons are the one that has mass. One atomic mass unit for one proton and one atomic mass unit for one neutron. So if you have an element with one proton and one neutron, you add that will be the mass. You don't add the number of electrons to that because electron mass is negligible. Is it clear?
Yeah.
Yes.
Yes.
I will use some examples as we go along, okay? Atomic number is the number of protons and mass number is the number of proton and neutron. So let's use an example here. Carbon, C for carbon, and C12 and 6. So you have a big number and a small number here. So what does the big number stand for?
Mass number.
Good, mass number. So that is your mass number. And the small number is our
Atomic number.
Atomic number.
number. Good. You will take the difference between the big and small number, that will give you the number of
Neutrons.
neutrons. Yes,
Neutron.
correct. So we have 6 protons, 6 electron, yes, and we have 6 neutrons. Yep. An atom is electrically neutral because it has equal number of protons and electrons. If you know the atomic number, you know the number of protons. And if we know the number of protons, then that will be the number of electrons.
Electrons.
Everyone is happy with that?
Yes.
I will give an example here, sodium, Na for sodium. So 23 and 11. So what is the mass number of sodium? Na for sodium. Sodium, so it is natrium, Na for natrium, okay? 23 is the mass number, 11 is the atomic number. You take the difference between that will be the number of neutrons. Yes, the number of neutrons and proton need not be the same. That's why I took another example here, okay? As you can see here, the number of protons and neutrons are not the same, yes? In the first case, it is the same. In the second example of an element, it is different. Everyone is okay with that?
Yep.
Yes.
In the periodic table, you can find the big number at the top or the bottom. It doesn't matter. Okay? The big number is always going to be the mass number.
Mass number.
Yes, the small number. It can be up, down, or it can be on the side. Doesn't matter. Okay? All right, isotope. Now, isotope has the same atomic number, but different mass
Mass number.
because of the difference in the number of
Neutrons.
Neutrons.
correct. For example, C12, C13, and C14. They all have the same atomic number. See? Only the mass number is different, right? So which means the number of neutrons are different. These are all man-made. The naturally occurring atom of an element is different from an isotope. They are all man-made. What they do is they bombard carbon with heavy particles, so it takes up neutrons and becomes an isotope. Any use of isotope? Isotopes are used in clinical medicine. For example, radioactive iodine, I-125, I-128, 131, and so on. So those isotopes are used. Radioactive iodine is used for, if someone has hyperthyroidism, what they do is they give radioactive iodine and then they take an X-ray of the thyroid gland and look at how it is. Or they also use radioactive substance for treating hyperactive thyroid. They kill the thyroid gland. Okay. So that is one of the use of isotope in diagnosis of the disease as well as in the treatment of disease. Okay. Same thing we do with C14 as well. So they do some labeled studies. For example, someone with peptic ulcer disease, we give actually a radioactive substance. A radioactive urea is given to the patient to drink, and then we actually capture the carbon dioxide which comes out of the person when they exhale. So there are a lot of uses which you will do in clinical medicine later. Okay. And remember, isotopes are man-made, or it can be also made due to cosmic radiations. Okay. If you are given a symbol with atomic number and mass number, you should be able to calculate the number of electrons, number of neutrons, protons, and so on. Yes? Are you able to do that?
Yes.
Okay. Location of subatomic particles, nucleus, and the shell. In the nucleus, what do we have?
Protons
The
and neutrons.
protons and neutrons.
Neutrons. And in the shell, we have the
Electrons.
Electrons.
electrons have shells. Remember, shell have subshells. Subshells have orbitals. We haven't gone into that much of detail, so don't worry too much. Okay. So each shell can accommodate only a fixed number of electrons. You can't push too many electrons into a shell. Okay. So the number of electrons in the shell, you can figure it out using this formula, 2n square, where n stands for
The
Shell
shell
number.
number.
shell number. So shell number 1 will have how many electrons?
2.
2.
2. So because
2 electrons.
2 times 1 squared. 1 squared is 1 times 1, which is 1. Yes?
Yep.
Shell number 2 times 2 times 2.
8.
8. Are you okay with that?
Yeah.
Yep.
So the
Yes.
number of electrons in the shell, 2n squares. Shell number 1, 2 electrons. Shell 2, 8 electrons. Shell 3, and so on. You can calculate that. 2 times 3 times 3. So that will be 18. And shell 4 will have 32 electrons. Okay. Now, I will pull the periodic table and show you how it looks like. Now, we have 118 elements. All the 118 elements are known. It's not shown here. So those 118 elements are shown in the newly published periodic table by IUPAC, which was published in 2019. This is not a 2019 one. This I took from a biochemistry textbook. Okay. So now you don't have to remember all the 118 elements, but you need to remember some of the elements. That's why I made a table here, or I highlighted which we have to know. Okay. H for
Hydrogen.
hydrogen. Lithium we need to know because it is related to health and disease. People with manic depressive psychosis, a psychiatric disorder, one of the medication there is given is actually lithium carbonate. That's why I highlighted lithium there. Okay. It's not naturally occurring in human body, but it's given as a medication. Okay. Li for lithium. And sodium, magnesium, potassium, calcium, titanium, because they use in orthopedics the titanium rods and so on. That's why I thought it's better to know what titanium is. Yes. Vanadium, so that's the micro elements. Chromium, manganese, Fe for
Iron.
Iron.
iron, ferrum or ferric, right? And the CO for
Cobalt.
Cobalt.
cobalt, nickel, Nickel, why I brought nickel here is, so they use a nickel cadmium battery for patients who have a pacemaker in their heart. Heard of pacemakers? Pacemakers are the one which controls contractility of the heart. So that small equipment which is implanted on top of the heart has a battery. So that's why I thought better to know about what nickel is. And nickel also is used as a catalyst for hydrogenation reaction. So when they make margarine, what they do is they hydrogenate the oil, unsaturated oil, needs a catalyst. Nickel or platinum as a catalyst they use. Cu4?
Copper?
Copper.
What?
Copper.
Yes, correct. Zinc. Molybdenum, M for molybdenum, so which is also a cofactor. Manganese cofactor, iron cofactor. We will learn more about cofactors when we look at enzymes. Heard of enzymes?
Yep.
They are biological catalysts. So many enzymes require cofactor, which stabilizes the active site. So we will come across many of these, metals as cofactors later on. That's why I thought it's better to have some idea. Okay. Ag for silver, argentum. Cd for cadmium.
Cadmium.
Cadmium is good for health? No. It's a heavy metal, it's a poison. Au for aurum, Hg for
Mercury.
mercury, hydragyrum. See, some of these words are not English, as you can see, right? So it is Latin. Okay. So the name of the element is derived from English words. It can be from Greek. It can be from Latin, or it is also derived from name of the places and so on. Like Californium is an example for an element. Okay, B for boron, carbon, nitrogen, oxygen, yes, silicon, phosphorus, sulfur, arsenic, selenium. Then you have group 7A. So those are the, what do you call group 7?
Halogen.
Halogens. And group 8?
Noble gases.
Yes. Noble gases don't take part in any chemical reaction. Why?
They're
They're
already
stable.
They are stable with 8 electrons in their outer shell. So all these atoms, other than group 8, want to have 8 electrons by losing, by sharing, or by gaining to satisfy octet rule. But these guys, they don't obey octet rule. What do you call those?
Transition.
Transition elements.
Transition element. They don't obey octet rule, but they are metals. See, metals are on the left-hand side of the periodic table, and here these are the non-metals, which is shown in yellow, non-metals. Metals lose electrons, non-metals
Gain.
gain electron. Or non-metals can also share electron to satisfy octet rule, except transition metals. Okay. And vertically you have the groups, and horizontally we have the, so this way is our period,
Period.
and that way is our group. Are you okay with that?
Yes.
Yes.
So I have highlighted some of these elements which you need to know the symbols and the names, because many of you will be doing nutritional biochemistry, I'm sure. So when you do nutritional biochemistry, so you are going to learn more about these elements and its functions. Okay, any questions so far?
Would you be posting this up onto the learning resources so we can?
Yes, I will. I'm recording this. I can put it as a recorded one. Is it all right that way?
Yeah, that's good.
That's perfect.
Okay, that's
Can
good.
I also ask, will
Um,
we have
I had a
copy
question.
of the periodic table for the exam?
You can open the periodic table, you can print it there, you can keep it in front where while doing the quiz.
And what about their final exam?
Final exam, you don't need the periodic table
Okay, thank you.
because the final exam content is from session 15 to 26.
Okay, all right, thank you.
Yes, session 1 to 14 will not be asked in the final exam. Is it all right?
Thank you.
Yes.
I had a question about the charge of the atoms. So when they ask you what's the charge of the atom, for example, in carbon, because everything is, let's say protons are 6, electrons are 6, and neutrons are 6, and that makes it like a neutral charge, as in like a 0 charge, because everything has been stabilized. But do you normally refer to the charge of a carbon, let's say, as in like 1 positive charge, 1 negative charge, and 1 neutral? Or do you say 6 protons is a charge, 6 neutrons is a charge, and 6 electrons? Like, that's just like, what is the charge of, for example, a carbon?
Whatever is given here in the periodic table is uncharged. Okay, so which means it should have equal number of
Protons and electrons.
and electrons. And why does an atom wants to be charged? To become
Stable.
stable. By losing, by gaining, by sharing. So that they get 8 electrons in the outer shell. So for example, when an atom loses an electron, the number of protons and electrons are not going to be the same. Yes?
Yes.
For example, let's take here sodium. Okay? Sodium has 11 proton and 11 electron. Now let's see how many electrons each shell is going to go. Okay? So we know there are 11 electrons, right? That's the nucleus. Outside the nucleus is shell number 1. How many electrons it can take?
2.
2.
2.
I'm going to show 2 electrons there. Okay, sorry. Now 11 take away 2, you have 9 now, right?
Yep.
Next shell, 1, 2, 3, 4. So what you do is you spread the electron as much as possible and then you start pairing. Okay? 2, 2, another one, another one. So how many electron in shell number 2?
8.
8 plus 2 is
10.
10. Now that's all it can take. Shell number 2, we know it can take only 8 electrons, right? And shell number 3 is going to have the lone electron. Is it going to be very happy with 1 electron there?
No.
No.
No, it wants to give away the electrons. 1 electron it is going to give. So when it gives 1 electron, you can see number of protons and number of electrons are not going to be the same. So it is going to have 1 positive charge. Yes?
Yes.
So metals are losers, right? So sodium loses 1 electron. So it is still sodium, but it is not sodium atom. It is sodium ion. Yes, it is an ion. Ions are charged. Now let's pick up chlorine from group 7. Okay. Now I will tell you the group number actually tells you the number of electron in the outer shell. Yes. Of the common elements. If you look at all group 1 will have 1 electron in the outer shell. All group 2 will have
2.
2.
all group 3A. Can you see A there on top? They are the common elements. 3 electrons, 4 electrons, 5 electrons. Group 6 will have 6 electrons in the outer shell. Yes?
Yep.
7 electrons and so on. Now let's pick up a non-metal. Chlorine, yes? Chlorine is 17. Yes? It says 17. So
Yep.
I don't have some space to draw here. Maybe I'll draw here in small, right? So how many electrons goes in there?
2.
2. So 2 there. And next one goes, how many electrons? 1, 2, 3, 4, 6, right? So 8 electrons there. So 8 plus 2, 10, right? So now how many needed?
7.
7 there. So you spread as much as possible first. So what am I showing here? Actually the electrons in the Lewis dot structure. Remember?
Yep.
Lewis dot structure?
Yes.
So where we are representing the electrons in shells. So you have 2 there, pair as much as possible there. So you can see there you have 7 electrons in the outer shell, right? Yes?
Yeah.
Yes.
So that's why it is in group 7. How many electron it needs?
1.
1 electron. Remember our friend
One.
sodium has given 1 electron, and that electron chlorine is going to accept, so it becomes an ion,
Sodium.
chloride ion.
Iron.
Yes? Makes sense now?
Yes.
Okay. Okay, so now the period. The period actually tells you how many shells you have. If you look at sodium, sodium is in period 3, yes? Horizontally. How many shells sodium is going to have?
3.
3. Look at here, 1, 2, 3. Yes? And chlorine is in
3.
3, 1, 2, 3. So the period tells you how many shells are there in that element. And group tells you how many electrons are there in the outer shell for representative elements or the common elements. Okay. So this is what I have
Sorry,
done.
can you just say that one more time?
Yep. The group number of the representative elements tells us how many electrons are there in its outer shell. And the period tells you how many shells are there in that particular element.
Thank
Yep.
you.
So I have shown you here to illustrate that. Okay. All right. So I have actually made a concept map for showing whatever we have done in this session. Chemistry is the study of matter. Matter is made up of atoms. Atoms are made up of subatomic particles. And what the subatomic particles are: protons, neutrons, and electrons. Protons positively charged, neutrons neutral, electrons negatively charged. Okay. Matter consists of elements. Elements are represented by symbols, which is shown in the periodic table. Okay. Elements are made up of tiny particles known as atom. Previously, you know, the scientists thought that atoms are uncuttable, right? If you use a very sharp Gillette knife, you could cut into small, tiny pieces, but you reach a point you can't cut further. That's what scientists thought. But later on, you know, they disproved it. Yes, you can cut it using sophisticated equipment into subatomic particles. Okay. And which is going to be our neutrons, protons, and electrons. Okay. Atoms wants to connect with other atoms. Okay. That connection is actually a bonding. If you look at oxygen and oxygen, oxygen is not stable as it is. So it needs another oxygen atom. So two oxygen atoms are going to join together to form an oxygen molecule.
Molecule.
A molecule is made up of more than one atom. Okay. If the molecule contains different kinds of atoms, then it becomes a compound. For example, if you look at water here, right? You have hydrogen and oxygen. Two different types of atoms there, right? So that's a compound. So carbon dioxide is also a compound. A compound is different from a molecule. If I say oxygen molecule, it is made up of only oxygen. Okay. A molecule can also be a compound. For example, here water molecule means it has hydrogen, two hydrogen and one oxygen atom. Okay. Now, where do you find the electrons? In shells. Shell number 1, 2, 3, 1 can take 2 electrons, 2 can take 8 electrons, yes, and 3 can take 18 electron, but you don't have 18 electron here, you have only 1 electron there. Okay, so that should be actually a sodium atom. Yes, I counted the number of electrons, you add up that will become actually 11. Okay, carbon, again 2 electrons in shell number 2, 4 electrons in shell number 2 there. So it is in group 4. Yes, it needs 4 electrons to get 8 electrons, or it can share 4 electrons with other non-metals. Like for example, with hydrogen, yes, it can share. So that's your next lecture actually. Okay. And matter is something which occupies mass and volume, and we use measurements which has unit and number. Body weight, for example, is expressed in kilograms. Different states of matter, solid, look at the particles, they are very closely packed. And liquids and solid. The interaction between the particles that make the liquid is lesser compared to solid. And in gas, there is no intermolecular attraction or bonding in gas molecules. So that's what you did in session 1. Any questions so far?
I have one.
Yep.
Just in regards to how can water be a molecule and also be a compound? I'm just a bit confused in that bit.
Okay. You know, water molecule, anything more than one atom is going to be a molecule actually. But
Yeah.
it is a compound because it has dissimilar atoms.
Okay, so you would call it a compound though?
It is
not
a compound,
molecule.
but you can also call it as a molecule, but you can't call oxygen as a compound, can we?
No.
No, yes. So there comes the difference.
So both are right if...
Both are right, yes.
Okay.
Yes, carbon dioxide is a carbon dioxide molecule. People refer to carbon dioxide molecule, yes?
Okay, yeah.
Yes, so they are right because it is made up of more than one atom, right? A
Yeah.
molecule should have more than one atom, but if it is of the same kind, you can't call it as a compound.
Yes, just a molecule.
Yes, like nitrogen, for example, N2. Okay?
Yes.
N2.
Can I just ask, do you add these flowcharts to the learning resources so we can print them out as well?
You want me to upload that one?
Yeah, I just wonder if that's part of your process so we can...
Yeah, I can do that.
Yeah.
No problem. I will PDF it and upload to your all participants so everyone gets.
Thank you.
Thank you.
This is actually what you need actually. You yourself have to do it. So I was giving time. So what I do is I prepared, I took a lot of time. I made all the sessions concept map. It is a concept map for every session I have done.
Fantastic. It'd be
Nice.
So
great to
I
be
will
able to get
upload that. Okay. By
It gives such a
itself.
good overview.
It is a good overview actually. This is, see, your 3 hours session, you are making it to one slide.
Exactly.
Now you can actually print it out and then put it there, you know. Oh yeah, you will come to know what we have to learn. This is what you have to learn in this particular session.
Thank you.
Thank
Good.
you.
Any questions so far?
Sorry, can I ask about the chemical equations and
Okay.
reactions, or not
Yeah.
yet?
You have it is coming
Okay.
up in the next session, okay? This for
All right.
session one, any problem with session one? Anyone has any issues with the session one so far? You are able to identify
No,
the
it's way more clear now.
okay. Elements, symbols. See, this is, see, from here you can actually add notes onto this. Okay. You print it out and you can add your own notes there. What chemistry is. So you take an arrow from there, study of matter. It's there. You know, you can fill in as much as you can there. Okay. Okay, moving on to the participation plus questions. Remember in your, again, every session has a 6 participation plus question. This we used to do actually in class. We give students time, they pair up, and then they come back with the answer in class. We give them about 2 to 3 minutes. Okay. So what is an electron shell? I have the answer there, right? An electron shell contains group of atoms, group of electrons with similar charges. Shell number 1 is going to have how many electrons?
Two.
Only 2 electrons, which orbit around the nucleus. They are with a similar energy. Okay. What is the order that the electrons shell 1, 2, 3 are filled with electrons, and why? Order of filling is going to be first 1, then 2, then 3. It is based on energy. Which one is going to have highest energy?
3.
Electrons in the shell?
3.
Shell 3. Yes. The lowest energy is attracted more towards the nucleus. The one with the highest energy is going to be farther away from the nucleus. And the number of electrons in a cell can be calculated using the formula 2n square. I have explained that. Yes, are you okay with that?
Yes.
Yep.
Does an electron positioned close to the nucleus have higher or lower energy? Electron closest to the nucleus is going to have the lowest energy, and farthest away from the nucleus is going to have the highest energy. Okay. The next set of questions there. So carbon 12. So what are the subatomic particles there? C12 and 6. Okay. 6 protons, 6 neutrons, and 6 electrons. Okay. Charge of different subatomic particles. We did explain that. Protons carry positive charge, electrons negative charge, neutrons neutral charge. Location of each of the subatomic particle also we did discuss, right? Protons and neutrons in the nucleus, electrons in the shell. Okay. So that finishes session 1. Now session 2, we did the valence electrons. Remember, the group number is going to be the electron in the
Outer shell.
the group number. So that's the electron known as valence electrons. Octet rule, which says atoms lose, gain, share electrons so that they get 8 electrons in the outer shell to become stable, or to get the electron configuration similar to the nearest noble gas. See, when these atoms lose, gain, or share, they are still the same element of the atom. It is not going to become a different element because it is losing or gaining or sharing only electrons. Nothing happens to the protons. See, remember the atoms or the elements are arranged in the periodic table with increasing atomic number. Yes? So which is actually the number of protons. Transition metals does not obey this rule. Okay, formula of a compound containing transition metals. So you have iron here, Fe, and chlorine. Iron is it a metal or a non-metal?
It's a metal, it's a
Metal.
transition.
So it is going to lose electron, right? Chlorine is
Yes,
non-metal.
going to get.
Chlorine is in group 7, it needs 1 electron. So from the formula, you can see there are 3 chlorines there, right? 3 chloride ions. So that means the charge of iron should be 3. We have 2 types of iron, which is Fe3 plus and Fe2 plus, ferrum and ferric. Fe3 plus means how many electron it has lost? 3. See, the number of electrons and protons are the same in every atom of the element, right? So if I am showing 3 plus means it has lost 3 electrons. Fe2 plus means it has lost
2 electrons.
Yes. So now here FeCl3 means iron. In Roman numerals we use chloride. Iron 3 chloride. So this is for transition elements. So transition elements which have more than 1 ion is shown with a Roman numeral. Okay. There is a slide which tells that. Same way with the copper. You can have copper 1 plus and copper 2 plus. Yes. Copper 1 plus is known as cuprous. Copper 2 plus is known as cupric. Same way, ferrous, ferric. You don't have to study all
I
the
don't really understand.
elements with more than 1 charge. These 2 you need to know, iron and copper. Yes, please. Somebody have a question?
Yeah, I don't really understand this.
Transition metals. See, metals
Yeah.
always form positively charged ion. Yes? By losing electron. The transition metals, they don't obey the rule. They can form more than 1 charge. They don't lose electron from the outer shell. That's why they are positioned like that. You simply have to remember this. That's all. There is no other way. Formula is given.
Wow. Okay.
In the compound. Can someone tell what are the elements present in that Ca3PO4?
Calcium, phosphorus, and oxygen.
Correct. Calcium, phosphorus, and oxygen. You have 3 calcium, 1 phosphorus, and 1, how many oxygen? 4 oxygen. So this is your, that's your subscript. The subscript tells you how many atoms are there. Subscript. That is subscript. Okay. Calcium phosphate. So polyatomic ion, group of atoms with a common charge. Here again, you simply have to remember the table given to you. Ammonium ion with 1 positive charge. Remember, ammonia is NH3. When it gains 1 hydrogen plus, it becomes NH4 plus. That's how ammonium ion is formed. It's a positively charged ion. See, that's your nitrogen. Yes. It's your ammonia. It gains 1 more hydrogen plus. A hydrogen with no electron is going to go and join. Yes. A hydrogen with no electron is what is known as a H plus. That's how it gets a charge there. Hydrogen carbonate, HCO3. Group of atoms with a common charge. That's polyatomic ion. Polyatomic ion. So if you have a compound NaHCO3, okay, so that will be your sodium hydrogen carbonate or sodium bicarbonate, which lives in our kitchen, right? Bicarbonate of soda. So group of atoms with a common charge. Sodium is a metal, one positive charge, and this one has one negative charge. So when you write a compound, the charge should balance. Like for example, sodium chloride, sodium and chlorine. Sodium is in group 1, one positive charge. Chlorine in group 7, how many? What is the charge?
Negative.
A negative charge. So that's why the correct formula for sodium chloride is NaCl. So let's.
So sorry, why don't the polyatomic ions why do they have a charge? What makes them different?
Because it is an ion. It's an ion.
Yeah, okay.
Yeah, because NH3 don't have a charge. It becomes an ion. Ammonia becomes an ion by gaining, or the poor hydrogen with no electron says, can I come and join you? Because this one has here, if you look at nitrogen, ammonia, that's the structure of ammonia. So here you have a pair of electron, okay? Each bond is a pair of electron, 2, 4, 6, and 8. Ammonia is very happy because it has 8 electrons. But this poor hydrogen with no electron says, I have only one proton with me. Can I come and join? It is going to share that 2 pair. It's the type of bonding known as coordinate bonding, which you haven't, there is not much mention about that in our lectures notes. Right? All right. Chemical bonding, which is a bit challenging. Covalent bonding is, what is covalent bond? Sharing of electrons. It can be equal sharing or it can be unequal sharing. So if it is equal sharing, then it is known as non-polar
Nonpolar.
bonding. And if it is unequal, then it is known as polar covalent bonding. I will explain that using some examples. Ionic bond is between oppositely charged ions. And then we have the correct formula, how to write the correct formula I have explained. So I will go back and use a different screen sharing. Okay, where is my bamboo paper? So I'm going to use this one. So can you see a plain screen here now?
Yeah.
Yeah.
Okay. So let's look at covalent bond. Covalent bond is always between
Non-metals.
non-metals. So we will pick up 2 non-metals. Okay. So hydrogen. Let's pick up carbon. Sorry. Carbon is in group 4. Yes. How many electrons are there in the outer shell?
4.
4 electrons. How many electrons it needs?
8.
It needs 8. So which means hydrogen is happy. Hydrogen with 1 electron, right? It's happy to share that. One more hydrogen comes and shares with that. Another hydrogen comes and shares with that. And another hydrogen. So now you can see carbon is going to have how many electrons?
8.
8 electrons. Happy? Satisfies the octet rule. Now hydrogen is going to have 2 electrons. Yes? Hydrogen gets the nearest noble gas is going to be helium. That is what has 2 electrons. Electron configuration of helium. It's not going to become helium. Only the electron configuration. See? This is sharing of electron. Hydrogen is a non-metal. Carbon is a non-metal. Is it a covalent bond? Yes,
Yes.
no?
Yes.
Yes.
Is it equal sharing?
Yes.
Yes.
Yes. Now let's
Yes.
look at oxygen. Oxygen is in group
6.
6.
6.
yes,
6, yeah.
group 6. So let's show the, so how many electrons now? So we need
2 more.
2 more. Okay, it needs 2 more electron. Yes, hydrogen with 1 electron says I am able to share that. Another hydrogen says I am able to share 1 electron. So now you have oxygen with 8 electrons. Yes, hydrogen with the 2 electrons, 2 electron. So the shape of the molecule is going to be like this. So that's your H, 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 and H. And here, look at oxygen is going to be sharing electron with hydrogen. Now, if you look at here, oxygen shares only 2 electron with hydrogen. Yes, remaining electron it is not going to share. So this is what you call unequal sharing of electrons. Yes, because electrons are not shared equally, poor hydrogen is going to be pulled to one side, oxygen is going to pull to the other side. So that creates a partial negative, partial positive charge there. Yes. So electrons, the shared pair of electrons spend more with oxygen than hydrogen. But hydrogen shares also. Hydrogen has some contribution here in sharing, right? So such a bond is known as polar covalent bond. Polar covalent bond. In polar covalent bond, you have unequal sharing of electrons due to a high electronegativity and a low electronegativity atoms. If you look at oxygen, oxygen has a very high electronegativity. Remember, electronegativity value increases from left to right. Yes, oxygen is on the right side. Yes, in the periodic table.
Yes.
Yes, so that means it is going to have a high electronegativity compared to hydrogen. Hydrogen is in group 1 and oxygen is in group 6. So one high and one low electronegativity value, you will always find polar covalent bond. Okay with that? The next type of bonding is ionic bonding. Okay? Ionic
Sorry,
bond
what did you
is
call it again?
sorry, ionic?
Ionic? Okay.
Ionic bonding, yes. It is between ions, yes. So the covalent bonding is sharing of electron. Sharing can be equal or unequal. If it is equal, non-polar. If it is unequal, it is known as polar. So ionic bond is always between ions, right? A positively charged ion is known as cation, and a negatively charged ion is known as anion. Between cation and anion, oppositely charged, they are going to attract. Attraction leads to what? Bonding. Yes?
Bonding.
Yes. So, positive, negative, yeah, why we live together, right? So that is what happens in ionic bonding. Metal forms cation, non-metal forms an anion. Now, how sodium ion is formed? Remember, sodium has 1 electron in the outer shell. So it is going to form sodium plus 1 electron. Chlorine with how many electron in the outer shell? 7, right? So that
7.
electron it is going to accept. So that means it is going to become Cl minus. So between sodium and chlorine, now you have sodium ion and chloride ion. The non-metal changes its name into an ID: chloride, iodide, bromide, nitride. See, all the anions, they change their name because they have gained electrons. You can figure out how many electron the non-metal is going to gain. How? From the group number. If you look at group 7, how many electron it needs? 1 electron.
1.
Group 6.
2.
Group 5.
3.
3.
Yeah, so you go from there. So you take the difference between 8 and the group number. Yes?
Yep.
For the non-metal. So that way you can figure out how many it is going to gain. The metals are always going to lose. Group 1 is going to lose how many electron? 1. Group 2, 2. Group 3, 3. Okay? Are you okay with that? Hello?
Yes.
Yes.
Yes. So
Yes.
now,
Yeah.
oh, sort of. Yeah. I will go back to the original slide now. I have to share. I will stop sharing this one and I will share the screen. Which one is that? Yeah. Okay, so where are we? So that's one. Yes. So correct formula, how to write the correct formula of a compound. You need to figure out which one is a metal and which one is a non-metal. From there, you can actually make out what is the charge. The group number is going to be its charge. Actually. Group 1 will have 1 positive charge. Group 2, 2 positive charge. Group 3, 3 positive charge. And group 4 is always going to actually share. But there is a compound known as sodium carbide. Sodium carbide. Okay. Mole concept. Mole is a collection of unit. Like 1 dozen means how many are there in 1 dozen?
6.02
No,
times
1
10
dozen is actually
26.
12, right?
What?
Same way, 6.02 10 to the power of 23. 1 mole of anything is going to have that many. 1 mole of carbon will have 6.02 10 to the power of 23. 2 moles will have double of that, right? 2 moles will have how many atoms there or molecules there? Double.
1.20 times 10
2 times 6
to
to 2 times
24.
10 to the power of 23, which is 12.0 times 10 to the power of 23. So if you are using a scientific notation, then you can change the decimal 1.2 10 to the power of
24.
4. Yes. So there is a trick there. Okay. Now, this is because of time. Yes, we have only 1 hour. So this is what I have put together in chemical bonding. Okay. Bonding between atoms. So that leads to formation of molecules or compounds. Oxygen is a molecule, water is a compound. Okay. So valence electrons in the outer shell, that's the one which is going to participate in bonding. If you have a paired electron, it is going to be stable, so it is not going to participate in bonding. And the unpaired electron is the one which is going to be contributing to the formation of bonding. Electrons are the one which participates in bonding. Okay. Connection between atoms, 2 atoms sharing, it is known as covalent bond. For example, methane, covalent bond. 1 atom donating electron, the other one gaining. So between oppositely charged ions, you have ionic bonding. So covalent bond, polar You can see here water, example for polar covalent bond, methane, non-polar. Two atoms sharing equally, sharing of electron, that is always between non-metals. In the case of ionic bonding, it's between metal and a non-metal. Metal loses electron, non-metal gains electron, becomes cation, anion. Sodium chloride is an example for a compound bonding. Polyatomic ion, group of atoms with a common charge. Ammonium ion, bicarbonate ion. Okay, so octet rule, atoms lose, gain, share electron so that they get 8 electrons in the outer shell. So that's the summary of question time. Hello.
Hi, I have one question. I'm sorry, this is just something that has been doing my head in.
Yes.
Why in the mole, for example, when they ask in one of the quizzes questions, it says in 10 mole of H2O, how many individual H2O molecules are present? And they are saying that in 10 mole is 6.02 times 10^24 square. I don't understand why it's like that when on the graphic it says that 3 mole is 1.81.
One mole, hang on a second. 1 mole is going to have 6.02 10 to the power of 23. Okay. Now 10 moles of water is going to have how many? 10 times 6.02 times 10 to the power of 23, which is actually 60.2 times 10 to the power of 23. Yes, correct?
Yes.
In a scientific notation, you need to change the decimal to the nearest whole number, which is going to be 6 here. You change from 60 to 6 means you are taking 10 here. So that way it becomes 10 to 24, 10 to the power of 24. This is basic math. Hope you have done at school this one, no?
I remember.
Don't remember that.
So that's, don't worry too much about that. You just to read chapter 1 of your Stalker. It tells you, scientific notations and so on. So just have a look at that one. It's a bit hard now because it's done probably at school. Okay. So I'll quickly go through participation questions, right? Chemical bond. What type of chemical bond allows hydrogen and oxygen atoms to form? Anyone? Hello?
Polar covalent.
Polar covalent bond, yes. Polar covalent bond, correct. Because oxygen is, remember I showed you this formation of polar and non-polar covalent bond. Oxygen is highly electronegative. It shares only 2 electrons with hydrogen. Which type of atoms are the electron most attracted to?
Oxygen, because it has a higher electronegativity.
Correct. The shared electrons are more attracted to high electronegativity atom than the lower electronegativity atom. So involved in the covalent bond, shared electrons are more attracted to oxygen than hydrogen. Okay. Why are the hydrogen atoms within H2O molecules with a positive and oxygen with a negative? Is it a true charge? Shared electrons are attracted to oxygen than hydrogen, as oxygen has high electronegativity. With the shared pair of electrons being more attracted to oxygen, so you get a partial charge there. I took it directly from the slides. It is there, answer. Okay. With the shared pair of electrons being attracted to hydrogen, hydrogen has a less attracted, means it's going to have a partial positive charge. Is it a true charge? No. It is not a true charge. It is not an ion. Ions are truly charged. Yes, these are partially charged. Next set of questions. Do two ions with opposite charge attract or repel?
Attract.
Attract.
Positive, negative attracts, negative, negative repels. Two ions with opposite charges attract ions with the same charge. What type of bond forms between positive metal ion, cation, and a negative non-metal ion? It will be ionic bonding. So does the sodium atom lose or gain electron when it reacts with the chlorine atom? Because to satisfy octet rule. How many electrons sodium is going to lose? Only one. Chlorine is going to gain how many?
One.
Sodium atom loses an electron from the outer shell, becomes positively charged ion. Chlorine atom gains one electron as it has 7 electrons in the outer shell, and it becomes chloride ion. Oppositely charged ion attract, forming an ionic bonding. Okay. So that's it. Now again, question time.
I've got a question, please.
Yes,
Just in regards.
I will share this one for that. Okay.
Thank you.
So that I can draw, you know. There is my drawing here. Okay. Yes. Go for it.
Just in regards to final exam.
Oh, okay. Two.
I know it's far off, but with the participation questions and the review questions,
yes.
would it be ideal to focus more on one of those or both of them equally for the final exam?
Final exam is from session 15 to 26. Okay. Nothing from session 1 to 14. Okay.
Okay.
So what you need as a preparation for the final exam is one, of course, your PowerPoints. Yes. Two, you need your tute questions. Three, you need in the PowerPoints you have participation plus. Okay. Each concept actually important.
Can everyone mute?
Sorry?
It's just really loud. It sounds like you're going double somewhere.
Okay, so maybe somewhere too loud or what is it?
All good now.
All good, okay, sorry. The tutorial questions and the review quizzes. So this is what you need to concentrate on. Are you okay with that?
Thanks very much.
Any other question, please?
Yeah, the Socrative questions or the Socrative part is every time I try to log into that, it doesn't work.
Actually, the Socrative questions were developed by somebody else, so he left our college. So we don't have the license for that. He had a license, so don't worry. The Socrative questions are exactly what you have in your review quizzes. So you won't miss anything there. Okay.
They also should be doubled up in the tutorial.
Yes, it is doubled up in the tutorial as well. So if you have done the review quizzes, you actually get the the tutorial question answers there. You don't get actually the general questions. So general questions are not included in the review quizzes. Any question?
I have a question about balancing chemical equations. Is that possible to quickly review that or not really? Oh, okay, great.
Yes.
So
possible. Let's take, for example, CO2 plus H2O. No, sorry. 1 minute. Other way around. Balancing chemical equation, okay? Combustion of methane. CH4, which is methane, oxygen, and you get CO2 plus H2O. So this is going to be your reactant, and that is going to be your product.
The product.
Product, okay. On the left side of the arrow, you have the reactants. On the right side, you have the product. The number of atoms on the reactants should always be equal to the number of atoms on the product. Now we will count the number of atoms here. How many carbon?
1.
1. How many hydrogen?
4.
How many oxygen?
2.
Here you have carbon. 1. How many hydrogen you have?
1. 2.
2. And how many oxygen you have? 3. Not balanced, right? So the easy way to fix this one is, so we have 4 hydrogen there. You have carbon is balanced. You have 2 hydrogen there. You can't change the subscript. You can only change the coefficient. A number which is in front of the formula is going to be your coefficient. So 4 there, 2 there. So I'm going to use a coefficient of 2 there. Yes? So now
yes, but why did you write, sorry, oxygen 3 if it, at the end of the product says oxygen 1?
Oxygen 2 plus 1, don't we have 3 there? You have 2 there, you have 1 there.
Oh, okay, yeah.
Yes? So
but
now,
not, you can't, oh, yes, sorry, yes.
Yeah, okay. So now what I'm going to do is I'm going to fix hydrogen by using a coefficient in front of water. So that becomes 2 there, because 4 divided by 2, I will get a number 2 to multiply with. So that means you have 4 hydrogen now. Yes? So how many carbon we have? 1.
Yes.
Yes. How many oxygen you have now? 2 and 2.
2
so
times, yeah.
2 times 2. So that means now
4.
you have 4. How many we have here? Only 2.
2.
How to make it 4?
Put the 2 coefficients in front.
You can't change the subscript. You can't.
Yep.
That's the correct. O2 is the correct formula, so you can use a coefficient in front of that. Okay? This is how you balance.
Yes, I understand the balance.
Sorry?
I understand the balancing. What I wasn't understanding is the representations of the coefficients in one of the review, in the one of the questions in the quiz.
Mm-hmm.
Is
Yes.
the one that I was just yeah. Maybe I should just wait till you finish this one and then.
Yeah, no, next session we will do that, because it is in the next session. I already have planned for that, you know.
Will you go through a bit more of the mold in the next session? Because I'm a little bit stuck with the...
Yeah, mold next, because we already overshoot the time, 15 minutes more, right?
Thank you.
Yeah, so I will go through that mold concept as well in the next session, okay?
Thank you.
All right, anything else?
I just wanted to know, sorry, I just wanted to know why in 8, for example, 8CO2, the representation will be 16 CO2. I know that the 8 is the coefficient is 8, then you will multiply 8 times 2, which is 16.
Yep.
But then if you represent the 16 CO2, which represents 16 CO2 compounds,
yep.
Why would it be represented like that? Because if I see that representation, I will think that I have to multiply 16 times 2, and that is 32.
32 oxygen atoms it is in that.
Yeah, but in this question it says that so if I have a coefficient of 8 and then CO2, what is the
I don't have the
alternate
question here, so sorry.
representation?
Let me just pull out that question. I have to get the question here, then only I can. Yeah, 1 minute. Give me a few seconds. I will actually. Is it in the tutorial question you mean?
It's in the quiz question number 4.
Okay, 1 minute. Give me a few seconds. I will log in. Okay.
Thank you so much.